Feel free to start whenever you're ready.
All right, perfect. Hi, everyone. So my name is Letizia. I am a NASA intern, a former NASA intern. I just did my internship this last summer. It was a remote internship because of COVID. And so, yeah, I just wanted to share my internship story with you guys today. I'm really open to questions, so feel free to ask any questions. And so, yeah, we'll go ahead and get started. So my internship was on artificial intelligence. We worked on tracking aircrafts. Some information about me before we get started. My name is Letizia. I'm here in Boise, Idaho, and I'm in an incoming freshman. I'm a freshman right now at Boise State University in Idaho. I'm majoring in computer science with a machine learning emphasis, and I just did my internship at the Glenn Research Center. All right, so the gist of my internship, the whole goal of it was being able to recognize plane numbers off of airplanes at airports. And so basically we would be using an axis camera that was able to track airplanes in the air, kind of like at terminals. And so the idea of this project was be able to make a box around where the tail number of the airplane is, and then be able to recognize characters inside that box. And so then we could take out those characters and be able to track the airplane and match it to any information. So this kind of explains the organization of this. This could seem kind of a simple thing, right? Because as humans, we can look at planes, we can read numbers off of them really easy, and then we can connect these to other things. But for a machine to do this, it's actually a pretty long process. And so you'll see we'll have some object detection, we'll have to do some text detection, and then some text recognition, and then we all put that into a final master code and do a final video output. So that was my final output of my internship, was a video. There was also a fun little machine learning endeavor that I had during the internship, and so I'll talk about that later as well. All right, so the very first step in being able to recognize these tail numbers off of airplanes is being able to see what an airplane looks like. I kind of like saw it as like teaching a small child, like if you not to teach a small child to be able to recognize these tail numbers, you first have to teach them what an airplane looks like. And so this is something that we usually don't think about, but it's actually really important for a machine to be able to understand. So in order to do this, I actually use a platform called TensorFlow. And so this is a really cool machine learning platform that is already pre-trained. And so in this image right here, you can see I found an image of some airplanes, and I found an image that was a little challenging. It had quite a bit of airplanes kind of smashed together, and then it had an airplane in different angles to the camera to see, kind of to test out how smart this was and see how well it'd be able to recognize these airplanes. And so you can see in the picture, it has the title of what it sees and then the confidence interval of how sure it is that it is an airplane. And so you can see it's actually doing pretty well. There's like an airplane on the air over here that you can see has quite a good 72% confidence interval. And the plane, the white one that's kind of horizontally, that's like the best case angle to the camera. That's doing almost 100% accuracy. So that was really good because I knew I could use this TensorFlow in order to be able to do the object recognition part of this assignment. All right, so the next step, so now we know what this airplane looks like, right? But now we need to see what all the text on the airplane says, because if we know all the text on the airplane, then we can say which of this text is a tail number. So in this text detection, we first ask, is there text on this image? And if there is text on this image, we have to detect and localize all the points where there is text on the image. So this part it gets a little more complicated than the object detection, right? As you can see in the picture, it drew this program that I had drew green boxes around all the places where it thought it saw text. And you can see it's drawing a green box around all of the windows too. And so I found this was kind of a challenge, was that it thought all the windows, because they're kind of outlined in white compared to like the blue airplane background, it can kind of seem like they're big O's or big E's. And so we'll see this how it turns out later. But basically some tools that I used in order to make this program that could draw boxes around any text that it saw, it's called OpenCV. So OpenCV is actually like a image processing library. And so it kind of gives you helpful tools to kind of filter an image, but like a black and white filter on it, any different kind of filters in order to be able to see color and different RGB values better. And then the second tool I use is called a deep learning model called EAST. And so this model is another trained model that was trained on a bunch of like street text images. So if you pass in like a bunch of street signs, like titles of restaurants, and it was trained on all this data. And so now that if I pass it in an image of an airplane, it's already trained on different data, so it can see different images and it can see, oh, this says text, and then there's like the logo of the airplane, that's text. It already knows this is all text. Okay, so now we know where this text is, but the machine, it actually doesn't know what the text says. This is something that we do really easily with our own brains. We see text and we can read it, but this is like a whole different second part for the actual algorithm. So this is called the text recognition. And so in order to do text recognition, we used another tool called Tesseract. And so this uses a machine learning model called long short-term memory. This gets a little more technical, which I'm not going to get too technical in this presentation, but basically it makes a pipeline of all these useful tools in order to be able to see which text matches with which letter in the airplane. And so you can see in this picture on the very bottom, we have a little Cessna plane that has the tail number that says F-HATZ. And so you can see I ran this image through this Tesseract program, and it was able to completely understand all the letters on it. And so you can see there's a few discrepancies. It thought like the little design of the little blue arrow was an equal sign, but that can all be filtered out. So it actually worked out pretty well. And so yeah, this is basically how the text recognition part was done. There was a bit of like processing that I had to go in and change some of the code and also mess with some of the training models in order to make it see my image specifically better, but this is the gist of it. Okay, so after I was able to implement all these tools, the pictures I showed you earlier were like the very best case scenarios, but obviously that's not really realistic, right? And so the reality of my project was that sometimes the orientation of the robot, the airplane, really screwed up how well it was able to see the image, because maybe on all the images that it was really trained on, it was very they were all very straight, the lighting was very good, and so if any image that I give it of an airplane wasn't very straight or the lighting was a bit weird, it would completely mess up the program. It wouldn't be able to really recognize any images. And so in order to mitigate this, I tried to do some orientation. I used OpenCV in order to orient some images. And so you can see on this Cessna airplane over here, it saw the S22, which wasn't exactly right of the actual tail number. And so when I rotated it, it did a little better, but also it didn't do super great. You can see it didn't really guess it right away. And so some reasons that I talked with my mentor about that, I was like, why is this happening? Why isn't it really recognizing it super well all the time? And so we kind of thought maybe it's because these EAST and Tesseract models that we're using in order to see these the text on airplanes, they're not really trained specifically for tail numbers, right, on airplanes. They're more trained for like street signs, titles of like grocery stores, these types of things. And so if they're not trained specifically on tail numbers, it can get a little tricky. But in order to mitigate this, we thought we might do some more pre-processing of images. You might be able to filter them so the tail numbers really stick out in the image. And we could also try to train our own text recognition model that's trained specifically on airplane tail numbers. And so this is where the machine learning endeavor kind of starts. Okay, so basically we tried to make our own machine learning model, and we tried to give it some images. And so to this project, I was very new to machine learning, and we're kind of really learning some new stuff. And so there was some things I did here that obviously you would have to train a model like very, very well with like millions of images in order to make it really well. But this was more like a learning type of thing. And that's something I really enjoyed about my national internship, is like they cared much more about how much I learned compared to the final product. And so just trying to train this model on my own, even if it didn't make sense, because it wouldn't be it wouldn't have very high accuracy because I don't have access to millions and millions of images of tail numbers, I still learned a lot throughout the process. And so you can see here, I split the slide up into natural images and also synthetic images. And so we thought we would train the model on these natural images of airplanes that we kind of scraped from the internet. You can kind of see a few. It's just like if we search airplane tail number on Google, I just download a few of those images, and you can see we have some tail numbers. And then for the synthetic images, we basically made a program that would create these synthetic tail numbers and then put them against these different colored backgrounds, so we could kind of challenge the machine learning model itself. So you'd get used to seeing some weird colors on some other weird colors. Okay, so this is kind of a snippet of the code. I thought it was just kind of cool to put in. You can see I'm using Google Colab and TensorFlow, and so I kind of made this model, and I'm adding different layers to it. And so I don't get too technical on this, but I thought it'd be kind of cool to see what the code would look like. So yeah, this is kind of an output. So when I ran this code, I have all these layers of different things that would help in the neural network that I'm creating in order to be able to recognize these tail numbers, right? And so an epoch is each like training session. And so you can see every time it started out with a pretty low accuracy. So basically I'm giving it an image, either a synthetic or an actual image, and then I'm splitting the data set and giving it another either synthetic or natural image, and then I'm testing it on one of the images. So if I train it once, I'm like, okay, this is what this image, here's the image, this is the numbers that are on the image, and then here's a new image, can you tell me the numbers on this image? That's basically what I'm doing. And so you can see the accuracy is getting high super, super fast. So at first it started with a 38% accuracy, and then it shot up to like 100% accuracy. So I was like, oh, okay, this is great, but isn't that kind of weird? Like, it's kind of weird that it's learning this quickly, right? And so if you go to the next slide, you can see this is kind of like the visual representation of what's happening. You can see the accuracy is like just shooting up. And so I was like, okay, that's a little weird. Why is this happening? And so this is like another example of what I would do is like I would give it this whole synthetic images of a test number. And so I would say, here's C. This is what a C looks like. And then I would re-give it the image, and then it would think that this C inside this tail number was an I. So it obviously wasn't trained very well. And so then later on, I would find, because I gave it a data set that was too predictable, it was too repetitive. All this, like, if you remember back from the slide where I showed all the data set, all the synthetic data set was very, like, it was too similar to each other. It's basically like if I wanted to train a machine learning model on cats and I just drew cats and colored them different colors, it would only be able to recognize the cats that I drew and colored different colors. So it wasn't a very good model. So yeah, basically from this, it was a very, we had a lot of fun with this machine learning model. We learned why this didn't work. And so that's one of the big lessons that I learned during my internship, is that like, it shouldn't really, it matters more of like what you learn and how much fun you had. And I had so much fun trying to figure out this machine learning model. We would do our own training measure, be like, okay, this is wrong. What's happening? Why is this happening? And so the internship was only 2 to 3 months. And so by the end of the internship, I was like, okay, so now we did some more pre-processing on the images, and it's able to guess tail numbers on airplanes much better. And so this is a snippet of the final video output that I have. So they gave me this video of airplanes just going around like taxiing on an airport, and then I passed in the East and Tesseract training models plus some of the more pre-processing that I did. And so you can see I wasn't able to get the video in time for this presentation, but you can see the screenshot. Basically, it would be able to have a box around the airplanes that it did recognize, and then it would have other boxes around text that it would recognize. And so I wish I could show you the video because it's kind of cool. All the airplanes are passing by, and then you can see it in real time recognizing tail numbers off of the airplanes. And you can see quite a few times it actually does guess them very well. So it's a great start for the project itself. There's a lot of like mitigations that could be improved on to make it more precise, but it's a good starting off, because this was they gave me this project as a way to like, we need to start off with this, and so see what you can do, and then we'll build off of this later. And I think, is this the last slide or then we're after? Okay, so yeah, this is kind of like an overall timeline of my project. I kind of talked about this already, but basically, we define mission success by being able to run a video stream and get out an output of tail numbers off of a video stream, which is what I would just show you. So we actually did achieve mission success. And so another thing I learned that it's really important to be able to define your success well, because and it's more about learning. And so do an amount of success that it would more focus on learning than just trying to get as much done as possible. And so yeah, we were able to train and test an OCR model and also run a video stream that was able to get all the tail number outputs. So other things that could be done on this project is the smart camera tracking, right? There's a lot of different parts to this project, because at first I was like, oh, okay, this is going to be great. Like we'll just have a camera recognize these tail numbers, super easy, right? But then there's a whole another thing that goes into the smart camera tracking of it, right? You have to get like some API control for the camera. You need to have like a HTTP connection to this web camera. And then another part of this project would be making an information hub where once you actually have the tail number that this machine recognized, you have to connect it to some flight data for each airplane. So it's like the airplane N91092, this is its location right now. This is its flight schedule right now. And then the very final step of this whole project would be actually implementing all of this system at an airport, which goes a bit beyond my own scope as an intern. So yeah, this was kind of the gist of my NASA internship. Feel free to ask questions, comments. I hope you learned something fun. I tried to make it like understandable for a wide audience. I had so much fun on my project. And also I have my email here. My NASA one, I'm currently not an intern right now, and so I won't be able to check that. But if you email my Gmail, I can totally respond to that. And I'm totally open to answer any questions of how I got my internship, my favorite parts of my internship, anything like that.
So yeah, I'll ask you some of the questions we got beforehand, and if anybody here currently has any questions, feel free to unmute or type them in the chat and I'll ask them. So the first question we got was, how did you land your NASA internship?
Yeah, that's a good question. So basically, it kind of started like a long ways back. When I started like in high school, I started doing First Robotics. I don't know if any of you are familiar with that, but it's like a global high school competition where we build robots. And so that's kind of how I got introduced to kind of programming and like all this more technical things. And so I totally fell in love with robotics. I would do it all the time. Like that's all I wanted to do. And so I did that from 8th grade until basically my senior year. And so I've done it for quite a few years. And then my junior year in high school, I was pretty experienced with the whole first game, and I had an idea of how to I wanted to improve on our robots, and so I was like, I want to reach out to a professor at my local university to be able to build kind of a system that would be able to localize robots in a field, which is kind of like a big part of the competition. So basically, I reached out to this professor. We did some research together. I published a paper with him, and then this professor was actually connected with some people at NASA. And so I had some connections at NASA, and so they recommended that I should apply for an internship for my final year. And so I did apply, and I applied my junior year, and I actually got rejected for my junior year. And then I kept trying, and then I reapplied my senior year, and then I got accepted. So you gotta keep trying.
Is there still work being done on what you helped start off, or was it sort of like a one-time project deal?
Yeah, no, there definitely is still work on it. My project is part of like a whole bigger initiative. And so they told me after I finished my internship, they said they would like me again this summer to keep working on the project. So on my project specifically, I don't think people are working on it right now. That's more of like something I would go back and work on. That's as far as I know. But there are people working on like the bigger overall project of aviation.
It looks like that's all the questions we have for you today. Thank you so much for your time.
Yeah, thank you.